Our next section is going to be 2.7, inequalities and absolute value equations. So let's actually start with an absolute value equation. So one of the things that you want to remember about absolute value is that there are actually multiple values that are going to make a certain statement true. So let's take, for example, the absolute value of 5. So if I were to ask in your own words, what would you describe absolute value as doing or representing? A lot of people would usually answer something along the lines of it takes whatever's inside and makes it become positive. Okay, so here, if the absolute value of some quantity x equals 5, I know that there are really two values that can make this true. Either x equals 5 or x equals the opposite of 5. Okay, so one of the things I need to do is I need to be able to account for these two possible cases for whatever this quantity is inside here. Now it could just be a single variable like this, or it could be a complete expression. One of the things that's very important though is that I need to isolate my absolute value prior to splitting it into two parts. Right? If you split the absolute value before you have isolated it, your first case is going to be correct, but your second case will usually not be. So when I take a look at the equation here to the left, I have 3 times the absolute value of 4x minus 1 minus 5 equal to 10. So again, first thing I want to do is isolate my absolute value here. So I'm going to add 5 to both sides. It's going to leave me with 3 times the absolute value of 4x minus 1 equals 15. I'm going to divide both sides by 3. It's going to leave me the absolute value of 4x minus 1 equal to 5. And from here now, I'm going to split this into two cases. Either my quantity 4x minus 1 equals 5, or my quantity 4x minus 1 equaled negative 5, right? And then the absolute value would have made it become positive 5. So from here, I need to solve each of these linear equations. On the left, we're going to add 1 to both sides. We're going to get 4x equals 6, or x equals 3 halves. And on the right, I'm going to add 1 to both sides. I'm going to have 4x equals negative 4, or x equals negative 1. So again, here I've got two solutions for my absolute value equation. Right? Again, when we're dealing with absolute value, we're typically going to get two solutions unless there are some special cases that happen. If I end up with an absolute value that say equals 0, I'm going to get the same expression or same solution twice. If I end up, when I simplify and I get an absolute value that equals, say, a negative number, this is going to give me a no solution. Okay, once I have the absolute value isolated and it's set equal to a negative value or a negative number, I know there's no real value that makes that true, so we would have a no solution in a situation like that. Okay? So let's take a look at one here. Right, I've got the absolute value of 3x plus 2 equals 4x plus 5. So here, my absolute value on the left is actually already isolated. So I'm going to split this into two. All right, so my two cases, I'm going to have 3x plus 2 equals 4x minus 5. Or I'm going to have 3x plus 2 equals, and it would have to be the entire opposite of the other side. So the opposite of 4x plus 5. Now, for you guys, you can probably just distribute that right away and it would be fine. All right, so here you would have 3x plus 2 equals negative 4x minus 5, but please make sure if you have more than one item or term on the right side, you must distribute a negative to all terms in case 2. So now I'm going to rearrange a little bit. Here I'm going to, on the left, I'm going to subtract 4x on both sides. Can give me negative x equals negative 7, or x equals 7. Okay. On the right, I'm going to, let's add 4x. Right, when I add 4x, I'm going to get 7x equals, and I subtract 2, I'm going to get negative 7, or x equals negative 1. Now, the one thing that is really important when we have absolute value equations, and specifically when I have a variable outside of my absolute value, right, I need to check for extraneous solutions. So I want to substitute back in. So when I plug 7 back into my original equation, on the left, 3 times 7 is 21, plus 2 is 23. The absolute value is 23. On the right, however, 4 times 7 is 28, plus 5 is 32. This is extraneous. On the right-hand side, the -1. When I substitute -1 in, 3 times -1 is -3, plus 2 is -1, the absolute value of which is 1. On the right, 4 times -1 is -4, plus 5 is 1. This checks out. Now, again, I mentioned this in one of the earlier videos, but in the event that you have somewhere you have extraneous solutions, I don't want you to get rid of the solution. I want you to put an X through the equal sign and write EXT underneath to tell me that you found it, but you also found you found the solution, but then you found that that solution happens to be extraneous and doesn't actually work for the original equation. Right? Put a check mark underneath the ones that work and box the whole thing. Okay? So again, one of the big tip-offs when you have an absolute or an X outside of your absolute value. What happened here is, if I do a quick sketch of this, I have got an equation where I have an absolute value that shifted to the left a certain amount. Okay? And then I have a linear equation that has a slope. It might look something like this. Okay? What happened is this linear equation has a slope that is steeper than the absolute values right-hand side, and I only have one point of intersection. Right? When I have the absolute value in the linear equation, which is what I really have here, it is possible that I get a line where I have a no solution, or maybe I get a line, depending on where things fall within the plane, where I have two solutions. So again, just a quick visual as to what's happening here, why we, in this case, got found two solutions and only one was true. Okay, in the other cases we could run into absolute value inequalities. When we have absolute value inequalities, I'm looking not only just at specific values, but I'm looking at ranges of values or intervals. Okay, so when we have absolute value inequalities, I have an acronym, and that acronym is GOAL, and it's going to help us to determine whether we end up with an or an and statement. So if, well, my absolute value is isolated, if the absolute value is greater than something, when I split it into two, I'm going to be separated by an or statement. If, when my absolute value is isolated, it is less than something, I'm going to have an and statement when I split into two. So let's go through and do the one on the left here first. Again, I have an absolute value right now that's isolated. I have absolute value of 1/3 x minus 2 greater than 5, or greater than or equal to 5. So when I split this into two, case 1, just as before, so copy it down as is. All right, so I have 1/3 x minus 2 greater than or equal to 5. Again, because the absolute value is greater than a quantity, we're going to have an or. My case 2, right? Copy my left-hand side, 1/3 x minus 2 down as is. I'm going to multiply the side opposite the absolute value by -1. But if you remember, when I'm dealing with inequalities, when I multiply or divide a side by -1, I have to switch the direction of the sign. So here I end up with 1/3 x minus 2 less than or equal to 5, -5. So now I'm going to go through and I'm going to try and solve my linear equations. Here I'm going to have 1/3 x greater than or equal to 7, or x greater than or equal to 21. Or we're going to have 1/3 x less than or equal to -3, or x is less than or equal to -9. And again, this or, right, I have a compound inequality, it's two parts. That is a part of my solution. If you just wrote the two inequalities here without the and or the or in between, I have to assume you don't know which one it's supposed to be, and I'm going to take a point away. Okay, so when I graph this, right, I have greater than or equal to, so both of my circles, or both of my points, are going to be filled in or closed points or circles. Okay, I'm going to point at -9 and a point at +21. I'm going to have all of the x values that are less than -9 and all of the x values that are greater than 21. Now, the or tells me that my solution could be out here in the part that's greater than or equal to 21, or any value from this solution or interval here on the left, less than or equal to -9, could be a solution of the original equation or inequality. Okay? So let's take a look at the second example. I'm going to do this two different ways. So I have the absolute value of 2x minus 5 is less than 7. So one thing I can do, it's less than, so I can split it. So I'm going to have 2x minus 5 less than 7, and 2x minus 5 is greater than -7. Okay, when I go through and solve, we're going to have 2x less than 12, or x less than 6, and we're going to have 2x greater than -2, or x greater than -1. Again, this and follows us down. So what I'm going to end up with here, I'm going to have 2 points. I'm going to have -1 and have a point at +6. These are both going to be open circles because neither include the endpoints. Now, the difference is, for a solution to be true from an inequality, it must be in both x, the interval x less than 6, and the interval x greater than -1. So if I have the interval x greater than -1, I'm going to have all these values here. All the values less than, or x less than 6, are going to be here. So what I'm really looking for when I say I want the values in the first and the second inequality is I'm looking for that area of overlap where both inequalities are satisfied. So we're going to get that shaded region sandwiched in the middle. Now let me do a slight rewrite of something. If you take a look at the part that I just underlined right there, I have 2x minus 5 greater than -7. I want to rewrite this just in the other order. So I want the -7 on the left and the 2x minus 5 on the right. Now think about if you go back to, probably grade school where the alligator ate the larger value. Here the 2x minus 5 is the larger value. So when I switch the order here, I have to also switch the sign. Now notice that these two are the same, right? And what I've now done is rewritten such that my endpoints are in least to greatest order. So what am I getting at? Well, when we have a compound or a absolute value inequality that is less than a number, I can write this as a 3-part compound inequality. I'm going to do so by taking the value on the right. I'm going to multiply it by -1. I'm going to put it on the left. So -7. My sign's going to stay the same, so less than 2x minus 5 less than +7. So here I've got the left and the middle, and the middle and the right, all written as one piece. Why this is nice is the fact that now when I go to solve the middle, whatever I do for one part, I do for all 3 parts. So if I add 5 to the middle, I'm going to have -2 is less than 2x is less than 12. And if I divide all parts by 2, I have -1 less than x less than 6. And did I not just in fact get exactly this inequality that is sandwiched in the middle of the graph that I did with the 2-part inequalities, sketching each and then finding the area of overlap? You don't have to do it this way. Okay? You can do it with the 2-part inequalities, but me personally, anytime I have an absolute value that's less than a number, I go straight to the 3-part inequality. I think it's more efficient, and at the end of the day, my answer comes out in a nice compact, already sandwiched in between the 2 endpoints form, and it just simplifies life a lot, if you ask me. Okay? So let's do 1 or 2 more examples. So here I've got 3x, the absolute value of 3x plus 6 is greater than 12. Again, the absolute value happens to be isolated, so I'm going to split it. So 3x plus 6 is greater than 12, greater, so or 3x plus 6 is less than -12. So I'm going to go through and try and solve. I'm going to subtract 6 on both, so I get 3x is greater than 6, which gives me x greater than 2, or 3x is less than -18, or x is less than -6. So again, here I know I have open circles, at -6 and at 2. For my first interval, x is greater than 2, so I'm going to shade to the right. And in my second interval, x is less than -6, and I'm going to shade to the left. Okay, it's an or, so it can be in the first or the second inequality or interval, and it's going to satisfy my inequality. One other thing you'll notice is I always write my interval or my inequality notation with the x on the left. And the reason I do that, for say x is greater than 2, this inequality symbol tells me which direction I want to shade. Here it's pointing to the right, I want to shade to the right. Okay? Here in this one, it's pointing to the left, I want to shade to the left in x less than -6. So just like a little trick that I think helps out quite a bit. Now, the one other thing that we want to take into consideration here is that we also want to be able to write this in interval notation. Okay, we talked about it the other week. This in interval notation. So each of my inequalities here, if you think about it, remember our endpoints would be -infinity and infinity here. So what I've got on the left is I have -infinity through -6, non-inclusive, union with, which tells me or, union with 2 through positive infinity. So again, this is saying it could be in the first inequality or first interval, or it could be in the second interval. Okay, so it's the think about the union of states in the United States. You could be in Pennsylvania, or you could be in Maryland, or you could be in Colorado, and you are still in the United States. You still satisfy living within our borders, okay, if you were in one of our states in the Union. Okay. So let's take a look at the next one. I have 3 times the absolute value of 2x plus 6 minus 9 less than 15. So again, I want to isolate my absolute value first. So I'm going to add 9 to both sides. It's going to give me 3 times 2x plus 6 is less than 24. I'm going to divide both sides by 3. It's going to give me the absolute value of 2x plus 6 is less than 8. Again, here I have an absolute value that's now isolated less than a quantity. I'm going to write a 3-part inequality. So -8 less than 2x plus 6 less than 8. I'm going to subtract 6 on all 3 parts. I'm going to have -14 less than 2x and less than 2. When I divide all parts by 2, I get -x less, or -7 is less than x is less than 1. Okay? And here now I know I have all the x values sandwiched between -7 and 1 are going to satisfy my absolute value inequality. Okay? Here, if I write this in an interval, right, I'm going to have all the values non-inclusive from -7 to 1. Let's do one more. So here I've got 3 times the absolute value of 2x plus 2 less than or equal to 14. So I'm going to isolate my absolute value. I have 2x plus 2 inside absolute value less than or equal to 14 thirds. I want to split this into 2, so I'm going to have -14 thirds less than or equal to 2x plus 2 less than or equal to 14 thirds. Okay, from here, now I'm going to go through, I'm going to subtract 2 from both sides. Common denominator of 3, I'm really subtracting 6 thirds. So when I do that, I'm going to have -20 thirds less than or equal to 2x less than or equal to 8 thirds. I'm going to divide both sides by 2. Then I'm going to be left with -10 thirds less than or equal to x less than or equal to 4 thirds. And again, I could graph that. If I did sketch a graph here, I would have the following. We would have all the values from -10 thirds through 4 thirds, 4/4, with closed circles. And I want all the values that are sandwiched in the middle. If I write this in interval notation, I'm going to have all the values from -10 thirds inclusive, so I'm going to use a bracket, all the way up through 4/3 inclusive. And again, I'm going to use a bracket for that endpoint because it's included. I'm going to skip this problem for right now, and we are going to take a look at absolute value applications in class because I think it's going to be a little bit easier to walk through and to discuss this problem face to face. A real quick refresher on circles. Okay, so our basic circle equation over here on the left, I have x squared plus y squared equals r squared. That's going to give me a circle centered at 0, 0, and with a radius of r. So an example there below is x squared plus y squared equals 16, which I could write as x squared plus y squared equals the quantity 4 squared. Thus, I have a center at 0, 0 and a radius of 4. Our general equation for the equation of a circle, and the one that you really need to remember, is here. Quantity x minus h squared minus quantity y minus k squared equals r squared. This is going to give me a center at the point hk and a radius of r units. Okay? So the example I have here is quantity x minus 2 squared plus quantity y plus 5 squared equals 9. This is going to give me a center at 2, negative 5 and a radius of 3. So let's take a look here. All right, if I want to determine the equation of a circle with a radius of 4 and a center at 1, negative 2. So I'm going to use that general equation, x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. Well, I have value for r, and I also have h and k. So if I'm given the center and I know the radius, I'm simply going to plug in. So here I'm going to get x minus 1, quantity squared, plus y minus negative 2, or y plus 2, equals r squared, so 4 squared, or you could write 16. Now, if I want to determine the center of a circle and its radius, and I have an equation of a circle that is in standard form instead of the general form. Okay, so I have something where everything's multiplied out. Right, what I'm going to do then is I need to complete the square on both the x values and also the y values so that I can figure out essentially what that x minus h quantity is and what that y minus k quantity is, and then also what r is. So what we're going to do is we're going to complete the square twice. Again, we have to do it for all the x's, and then we'll do it for the y's. And whatever we complete the square with, we add to the other side of the equation both times. So you guys can look at that example, but let's go through and do one live. So here I've got x squared minus 8x. And actually, let me go back and read there. X squared plus y squared plus 8x minus 10y plus 37 equals 0. So what I want to do is group everything by the x's. So I have x squared minus 8x plus a blank plus y squared minus 10y plus a blank. And I want to take that 37 and I want to move it to the other side. So I'm going to have negative 37 plus my first blank and plus my second blank. So what I'm going to do now is I'm going to take 1/2 of my middle term 8 here, 8x, negative 8x. I'm going to have negative 4. And I'm going to square it. And I'm going to have 1/2 of, excuse me, my middle term for the y is negative 10, which is going to be negative 5. And I'm going to square it. So on the right hand side now, I'm going to add 16 and 25. Okay, so here on the left, I'm now going to complete the square for this quantity and for this quantity with the y's. So what we're going to have is x minus 4, quantity squared, plus y minus 5, quantity squared, equals, and on the right hand side then, here I'm going to have negative 37 plus 41, so I'm going to have a positive 4. So this is going to give me, if I simplify one more step, x minus 4, quantity squared, plus y minus 5, quantity squared, equals 2 squared. So I have a center at 4, 5, and I have a radius of 2. So the last thing that I have here is that I've got a circle with a center at a 0.49 that passes through a 0.25 on the circle. Okay, so I know a point on the circle and I know the center. So here I know H and K, and here I know X and Y. There are two ways I could do this. I could use the distance formula to find the distance from these 2 points, or I could substitute in to my equation of a circle, and I could solve for r. I mean, really, if you think about it, this, if I took the square root of both sides, the equation of a circle is nothing more than the distance formula with different letters in it, right? Instead of x sub 2, x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared, underneath my square root equals to the distance, right? I've just simply got my equation of a circle, again, which is nothing more than an applied version of my distance formula. So here I have a center, I have a point xy, I'm going to substitute in. So x minus h, I'm going to have 2 minus 4, quantity squared, plus y minus k, I'm going to have 5 minus 9, quantity squared, equal to r squared. So 2 minus 4 is going to be negative 2, negative 2 squared is positive 4, plus, excuse me, 5 minus 9 is negative 4, negative 4, quantity squared is going to give me 16, equal to r squared. 16 plus 4 is going to be 20. If I take a square root of both sides, square root of 20 is going to break down into 4 times 5, so I'm going to have 2 square roots of 5 equals r. So now I know my radius, it's 2 square roots of 5, and I know my center, 4, 9. So what I can do then is I can substitute in, and we're going to have x minus 4, quantity squared, plus y minus 9, quantity squared, is equal to, and you can either write this as 2 square roots of 5 all squared, or you could simplify that and write it as 20. Okay. So here I now have my equation of a circle, right, given the center and any point that lies on the actual circle itself, right? Let me know if you guys have any questions, and I will see you guys tomorrow.